Hi, Assalamualaikum. My name is Fatihah Binti, and for my final year project presentation today, I will be presenting the title, "The Effects of Pretreatments on the Quality of Fried Potato Chips." So this will be the content of our presentation today, starting with the introduction. Potato or Solanum tuberosum have a potato tubers that are starch and protein rich, as well as containing carbohydrate, reducing sugars which are called glucose and fructose. Potato chips is a popular staple food that are made by deep frying thin potato slices in various oils and fat at temperature that are usually between 160 degrees C and 180 degrees C. Potato chips tend to contain more than 20% of oil that are majority derived from frying oil. The fat or oil used in frying process improves the organoleptic quality, which then produces a distinctive taste and the overall deliciousness of the potato chips. Next, we move on to a problem statement. The problem statement for my thesis is the potato development Maillard reaction products such as acrylamide rises when it is cooked at a high temperature, which is more than 120 degrees C. Maillard reaction also causes discoloration. Potato chips are regarded as harmful because to their high quantities of fat, salt, and acrylamide. High fat and calorie content of fried meals may raise the risk of unfavorable health outcomes such as obesity, hypertension, cardiovascular disease, diabetes, and also cancer. Next, the significance of my study is providing a better knowledge of which pretreatments are the best alternatives to prevent harmful consequences of fried potato chips such as high quantities of fat and acrylamide emerge as a result of using a high frying temperature. Now we're moving on to the research question. What is the problem with fried potato chips? Does the temperature of the frying process affect the quality of potato chips? What is the most effective pretreatments before the frying process that improves the quality of potato chips? The objectives of this thesis is first to review the frying temperature effects as well as the problem with the fried potato chips, and lastly to review the type and effect of pretreatment before the frying process on the quality of potato chips. Now we're starting with the first literature review, which is frying temperature effects. Now, potato chips are usually made by deep frying a thin slices of potato slices in various oils and fat at a temperature between 160 and 180. Now, there are problems that may have causes during this frying process. First, it is high frying temperature enhances dryness at the surface and water migration from inside to the exterior of fried foods. So it causes a low moisture content, therefore decrease the appearance of the potato chips. Second, heat and mass transfer cause oil on the surface of the fried potato pieces. Thus, pores occur on the surface of the fried potato chips. The third problem is oil content increase when frying them also increase. The fourth is the fat content of fried potato chips is eventually created as well. Reducing sugars in potato take part in Maillard process by interacting with the amino groups of free amino acids. So it resulted in an unappealing dark brown on potato chips. Maillard reaction also produces acrylamide that is also known to cause cancer in humans. And the last problem that may arise in frying potato chips is that acrylane caused by frying may potentially create an indoor pollution. It is a hazardous chemical that is created during the hydrolysis of triglyceride that can cause eye irritation as well as respiratory problems. Moving on to the second literature review, which is starting with pretreatment effects, and the first one is ultrasound. It is an oil absorption of potato chips was low is when the starting moisture level also low. By increasing the ultrasonic power and the treatment time, the moisture content will also lower. Because of the concentration of gradient, water can escape from potato chips tissues and make its way outside of the chip. Increasing the ultrasonic power and the treatment time can cause the breaking force to reduce. Therefore, low breaking point indicate that it become crispier. Ultrasound treatment can cause higher value of L. Using a good combination of ultrasound frequency and timing such as 140 kHz for 30 minutes of ultrasonic treatment leads to a greatest moisture diffusion from the potato chips for potato slices. Therefore, potato chips do not need to be cooked for a long time at a high temperature. Therefore, oxidation can be reduced. Next, blanching. Blanching raw potato slices before frying has been shown to reducing acrylamide generation by roughly 60% and gelatinize the starch on the surface, preventing additional oil from entering the fried potato. Blanching is significant because it helps eliminate reducing sugars from the surface, thus lower the acrylamide concentration. Blanching pretreatment is used to avoid formation of off flavors and color changes caused by enzymatic reactions, as well as to reduce the initial microorganism load. By lowering the timing and increasing the temperature will lessen the oil absorption. Based on past research by Paunovic et al. 2021, it is recommended that blanching and timing temperature to be at 3 minutes at 85 degrees C for 3 minutes, as it is shown to have a lower oil absorption by 43.3%. Next, soaking in calcium hydroxide solution. Calcium hydroxide solution inhibit the Browning reaction of calcium ion against amino acids due to absence of an enzyme. Potatoes are submerged in calcium hydroxide because calcium binds to pectin in the tissue. This connection is responsible for the potato's firm texture, which in turn makes its tissue structure more robust. The toughness makes it less likely that any water will evaporate when frying, hastening the creation of crust and also reducing the quantity of oil it will soak up in the process. The potato soaked in 1% of calcium hydroxide has lower fat content, which is by 10.92% due to more starch than potato immersed in 0.5% calcium hydroxide, which is 15.61%. Because in potato tissue, calcium and pectin combine to create a link, the stronger tissue structure, which inhibits the process of water evaporation during frying, so that the water evaporates minimally and increases the production of crust, resulting in a low amount of oil absorbed by the material. However, the moisture content of potato chips soaked in 1% calcium hydroxide was 3.52% and whereas the 0.5% of calcium hydroxide was 1.41%. Therefore, the lower percentage of calcium hydroxide is better for the quality of potato chips. The quality requirements of potato chip is maximum moisture content of 3%. The high moisture in treatment of 1% calcium hydroxide is due to the high element of calcium in 1% calcium hydroxide, which then absorbs water when soaking. Next, edible coating. Hydrocolloid coating improves surface characteristics, exhibit good ability to provide barrier properties against oxygen, carbon dioxide, and lipids, and offer great potential to decrease fat or oil absorption in fried potato products. Hydrocolloid coating of fried products alters its water holding capacity, stops the surface from drying out, makes the fried food more brittle and less porous, which then lessens the amount of oil it absorbs. Many coatings based on polysaccharides claim to be oil resistant, so it makes oil uptake in potato chips greatly reduced. The fat content of potato chips was said to be reduced by 57% when coating with 1% carboxymethyl cellulose (CMC). Next, infrared blanching. Infrared radiation is a form of electromagnetic radiation that transfers heat directly from products emitters to the surface user want to heat without warming the air around it. And this surface happens to be the potato chips. Due to product moisture and oil content, infrared blanching is more effective than water blanching. The color analysis L, A, and B values of the water blanch decrease at first, but it also grew as the process proceeds. Infrared blanching helps in the improvement of the quality of potato fry because of such gelatinization of the core inside and the production of a crust on top, as well as the formation of elastic white skin. Infrared also increases oil absorption during frying. Infrared blanch fried potatoes at a temperature 146, 160, and also 174 degrees C has the percentage of 37.5%, 32% and 30% respectively, less oil than fried potatoes that have not been blanched. And the last three segments for my thesis today is drying. The quantity of free water present on sample surface influences the L value when the drying time is lower, but the frying period is long. Non-enzymatic browning process decrease the brightness. 0 minutes, 10 minutes, and 20 minutes and 30 minutes of pre-drying at a constant temperature of 60 degrees C was applied. However, it shows that longer drying time also lower the moisture content of potato chips. Therefore, potato dry with 20 minutes and 30 minutes have the maximum hardness, which also means crispy texture. So, the pre-dried samples required less frying time to enhance the hardness value. This was significant since lowering the frying time lowered the oil content as well as the danger of acrylamide generation. Now, to conclude my thesis presentation today, high frying temperatures and time causes oil absorption, enhance dryness, lower the moisture content, cause Maillard reaction, thus decrease the appearance of the potato chips and produce hazardous products such as acrylamide and acrylate. Second, ultrasound blanching, soaking in calcium hydroxide solution, edible coating, infrared blanching, and drying treatments before the frying process improve the quality of potato chips. Now, the suggestion and recommendation for my thesis is future studies should be applied on the combination of the pre-treatments methods that discussed in this review to improve the quality of fried potato chips. Last but not least, to further assess the other pre-treatments to improve the quality of fried potato chips. Now, this will be the references I have used in my presentation today. This is my Gantt chart. Thank you for listening.